In this video, we will look at the technical details of some of the key big data components. We will look at streams type processing and text analytics in particular detail before moving on to look at some of the futures of big data and cloud. Business sentiment can be garnered from free-form text documents such as social media, machine log, call center logs, email, financial service documents. An AQL extractor consists of a collection of views, for example name, title and organization. Out of these, some output views, for example, we might be interested in a composite name, title, organization view as the final view of interest for the business problem. Dictionaries are used to hold titles and organizations. Personal names are recognized by their structure of first name and last name, with possible middle initials or prefixes, postfixes on the last name. The particular program in this case could be used to extract and match these three fields from a relatively free-form text document and provide the data for insertion into, for instance, a database table, or at least provide it in table format. The diagram shows the AQL execution model details. The picture shows the architecture diagram of a text analytics component. The example used here is based on the annotation query language, AQL, which is modeled after the SQL query language. The AQL developer writes the business logic in a .AQL file. The AQL program is declarative, that is, expresses what needs to be done rather than how to do it. The AQL program is next compiled by the Text Analytics Optimizer into an execution plan in the form of annotation operator graph file with suffix .aog. The optimizer is highly efficient and picks the best performing and optimized plan for execution. This .aog file, or compile plan, is an executable that can be incorporated into a runtime environment to handle either streaming data with InfoSphere streams or data at rest with InfoSphere Big Insights. The Text Analytics Runtime component is a document at a time execution model. The runtime component executes the .aog plans against the input documents and populates the output views with the extracted results. Similarly, we could run a text extractor to find sentiment. Here is analysis of comments on the movie RA.1. You'll notice the adjectives we picked up are an indication of positive, negative, or neutral sentiment expressed by reviewers. Most of the reviewers have used negative adjectives, which explains why the overall rating for the movie is low. The center column outlined in red shows sentiment. The left and right columns show the context of the comments. This context could have been used in the previous example dealing with names, titles and organizations to associate a name with a title and organization based on proximity within so many characters of the name. This diagram shows how IBM InfoSphere Streams works. The overall application is composed of many individual operators, or perhaps processing elements consisting of one or more operators each. These are the bubbles in the graph. The data packets, sometimes called messages, we call them tuples, generated by one bubble, travel to the next downstream bubble and so on. The technical name for the bubbles in the diagram is operator. Sometimes the output from one operator becomes input to multiple operators. Conversely, sometimes multiple output streams merge as input to one operator, but the tuples keep flowing. Note that we're doing continuous ingestion and continuous analysis on a stream of data in the form of tuples. Having all of these separate processes work together gives us flexibility and scalability. If we need more power than a single operator can provide, you can simply distribute the operators over multiple boxes or hosts. You can achieve scale by partitioning applications into software components, by distributing across stream-connected hardware hosts. Some compute-intensive operators get their own very own box. Other operators are best placed in the same box because they must exchange a lot of data, and going across the network would slow that down. The stream's runtime services can help distribute the load. In the picture, the streams flowing within a host, inter-process communication, have turned red, indicating that they are faster than the blue ones that go across the network between hosts. Finally, we label some of the boxes with some of the processing stages typically found in many stream solutions. Filter or sample to reduce the amount of data flowing through the system. Transform to change the data format. Compute new quantities. And drop unneeded attributes. Correlate to join or otherwise combine data from multiple sources. Classify is based upon models generated from historical or training data. Annotate is used to enrich the data by looking up static information based on keys present in the data. IBM InfoSphere Streams is one of a class of streaming data processing systems. It's the oldest and the most advanced, owing its origin to a large contract with the US Government Department of Defense. Development is based on System S software, S for Streams, that goes back to soon after 9/11. The first non-government customers were added in 2009. The other streaming data processing systems are much newer and often have very small development teams. Thus, for instance, Nathan Mars was the sole developer of Storm until its acquisition by Twitter. Storm programming is done in Java. InfoSphere Stream programming is done in SPL, Streams Programming Language, a high-level language that's compiled down to C++, and then runtime code is generated from the C++ derived code. Some of these packages are now open source and will become important in the future. In the meantime, package features, user experience, and a strong customer base are important in selecting which software package to use. The conceptual flow shown above is driven using the Big Insights app framework. The Big Insights app framework is leveraged by the data scientist to run the analytics components of the SDA, Social Data Analytics Accelerator architecture. The Social Data Analytics SDA Accelerator provides code assist to facilitate analysis data in real time for extracting insights, buzz, sentiment, intent, using sophisticated text extractors. In addition, social media analytics can be used to build consumer profiles based on context accumulated over time. Real-time insights are derived by running analytics on the streaming engine. Real-time analytics, as well as consumer profile information, can be made available on InfoSphere Big Insights, IBM's Hadoop distribution, for more comprehensive analysis as part of a comprehensive big data platform. Let's look briefly at some of the futures for big data processing and for cloud processing. An important area for future processing capabilities is SQL for Hadoop. This is part of the no SQL movement, not only SQL, better described perhaps as not only relational databases. Since SQL is going to be used, but the underlying data will be held in format containers other than a relational database management system. This is heading slowly towards full ANSI support. The candidates here are Hive, Impala from Cloudera, Big SQL from IBM, Stinger from Hortonworks, Drill from MapR, HAWQ from Pivotal, SQLH from Teradata. Big SQL from IBM is already available with full ANSI 92 SQL support, with a comprehensive optimizer, etc. Remember that IBM developed the original relational databases and the first implementations of SQL anyhow. Other areas for the future are improvements in multimedia analytics, growth in usage and adoption of the R programming language. IBM has just released Big R, integrated with streams and Hadoop processing. For the cloud, we can expect bare metal support, helping with Hadoop workloads, private networks, full support of APIs. Here are some features of Big SQL from IBM. Big SQL fully integrates with SQL applications and existing business intelligence data warehouse tooling, with benefits that include existing queries running on no or few modifications. It's ANSI 92 compliant. Existing JDBC and ODBC compliant tools can be leveraged. Applications do not have to compensate for constraints of HiveQL, which otherwise require more statements and potentially moving more data over the network to the application. You have now completed this video.